We're going to be working with the Pythagorean Theorem, specifically with radicals, which is actually a geometry teak, but it will help ease you into as you take geometry next year. Let's first of all just review a little bit on Pythagorean Theorem. It only works with right triangles, and it helps you find the length of a missing side. So the formula is a squared plus b squared equals c squared, where a and b are two legs, and then c is your hypotenuse, which is your longest side. So on 1, 2, and 3, we're going to just practice finding the missing side, just like you did back in 7th, 8th grade math, something like that. So we have a squared plus b squared. So remember that those are the two legs. So in this particular one, you're going to have 3 squared plus 4 squared equals c squared. So this will be 9 plus 16, which is 25, equals c squared. Now, if we want to find c, we need to get rid of the squared. So to get rid of the squared, we take the square root. Whatever you do to one side, you do to the other. A square and square root cancel out. So c is equal to 5. So, and this is the longest side, so that would turn out 3, 4, and 5. All right, so we're going to do the same thing on number 2. We have 5 squared plus 12 squared equals x squared. So this will be 25 plus 144 equals x squared. And that gives us 169 equals x squared. Square root, square root of 169 is 13. So that would be the longest side. All right, number 3. Now this one, we have the hypotenuse is given. So we're going to have x squared plus 9 squared equals 15 squared. So x squared plus 81 is equal to 225. So on the other ones, we squared and added. This one, we're going to subtract because we have to get x squared by itself. So we're going to have x squared equals 144. Take the square root. Square and square root cancel out. The square root of 144 is 12. So x equals 12, which is a leg, so it has to be shorter than the hypotenuse. Okay, now let's take a look here. We have radicals given on some of the lengths of the sides of this right triangle. So it says find the missing side length. Simplify the radical, if it doesn't reduce to a whole number. So we have a squared plus b squared equals c squared. So we're going to do 2 squared plus 2 square roots of 3, and all this is going to be squared, equals x. So 2 squared is 4. So remember what we did, 2 square roots of 3 squared, that's 2 square roots of 3 times another 2 square roots of 3. So this will be 4 plus 2 times 2. Remember we pull those out, 2 times 2, and that's 4 square roots of 3 times 3. So that's a pair, and we circle it. So we're going to have 4 plus, we bring out a 3 and multiply by 4, so that'll be 12. So 4 plus 12 is 16. Oop, you know what I forgot? This has to be squared. Equals x squared. Equals x squared. So let me go back. Totally forgot. Equals x squared. This will be 16 equals x squared. And then we take the square root of it. So this is equal to 4. There we go. Because when I found out that a side length is 16, I'm like, ooh, that's really big when the other ones are 2 and 2 square roots of 3. So this one is 4, which is your hypotenuse and your longest side. All right, number 5. So this time our hypotenuse is given in one leg. So we're going to have 3 square roots of 2 squared plus x squared equals 12 squared. So this is 3 square roots of 2 times 3 square roots of 2 plus x squared equals, and I can go ahead and tell you that 12 squared is 144. So here we have 3 times 3 is 9. Now, just as a little shortcut, you know what happened over here on problem 4 when we had 3 times 3, and that's a pair and it pulls out? Well, the same thing's going to happen with the 2's. If I put them underneath a radical, they're going to be the same numbers, so I circle and bring them out. So basically, it's going to be 9 times 2, and then plus x squared equals 144. So 9 times 2 is 18, plus x squared equals 144. Then I subtract 18 from both sides because your hypotenuse is given. So x squared is going to be equal to 126. And then I take the square root of that. Now, 126 is not a perfect square. 126, I think, is actually somewhere around 9.14 or something like that, which it has to be less than 12. So that would be a reasonable answer. Or you could just leave it as the square root of 126. All right, let's go ahead and take a look at problem 6, which is on the back. So we have, let's see, 3 square roots of 6 squared plus the square root of 5 squared equals x. So this is going to look like 3 square roots of 6 times 3 square roots of 6 plus the square root of 5 times the square root of 5 is equal to x. Oh, and this has to be squared. So 3 times 3 is 9 right here. But remember what happens if I put the 6's underneath. So basically it's going to be 9 times 6, which is 54. Plus, if I do the same thing with these, the 5's, I put them underneath one radical, it's going to be a pair, so I bring them out. So 54 plus 5 is 59. And you can leave it as that, or you can figure out that the square root of 59, is actually square root is about like 7.7, which it has to be more than 3 square roots of 5. So this would be, 7.7 or whatever. So just leave it as x equals the square root of 59 right here. But just to determine if you are in the ballpark, it does have to be more than 3 square roots of 3. All right, number 7. So we're going to have x squared plus 5 square roots of 2 squared equals the square root of 122 squared. So this is going to be x squared plus, 5 square roots of 2 times 5 square roots of 2. And then, as a shortcut, the square and square root cancel out. So you're going to have 122. So we're going to have x squared plus, 5 times 5 is 25 times that 2. So 25 times 2 gives you 50. Then we're going to subtract 50 from both sides. So x squared is equal to 72. Take the square root of that. Now 72 can actually be simplified, not just to a decimal, but it can be simplified by taking factors of 72. I'm going to choose 9 and 8. The reason, because 9 breaks down into 3 and 3, which are prime numbers. And 8, remember what 8 is? That's right, it's 3 2's. So I have a pair of 3's and a pair of 2's. So that'll be 3 times 2, which is 6 square roots of 2. So x is going to be 6 square roots of 2. All right, there's a review. Lovely. Okay, so on number 8, it's just multiplying, which is what we've been doing. 3 times 5 is 15. 8, 1, 2, 3, and 10 is 2 times 5. So I have 1 pair of 2's, 2 pair of 2's, so that's 2 times 2 is 4 times 15, so that's 60 square roots of 5. The other one, we've been doing this. So this is times 4 square roots of 2. So 4 times 4 is 16 times 2 gives us 32. Got that. 10. Find the quotient Okay, so we can divide, or you can take x plus 5, which is right there, right here, and multiply it by one of these answers to see if it will give you 2x squared plus 4x minus 7. Let's go ahead and divide because we haven't done that in a while. So we're going to have x plus 5, and then we're going to have 2x squared plus 4x minus 7. Let's change colors. I'm tired of red. Okay, so 2x squared divided by x gives us 2x. So 2x times x is 2x squared. This should be the same term right here because they're going to cancel out. And then 5 times 2x is 10x. Draw a line and change both signs. So those cancel out. So 4 minus 10 is negative 6. X minus 7. And then negative 6x divided by x is negative 6. So I'll give us negative 6x. And 5 times negative 6 is negative 30. Draw the line and change both signs. So that'll give us 23. So basically we wouldn't have been able to find this had we tried the FOIL method because we have a remainder. So the quotient is the number up here. Now, if it would have asked for the remainder, then we would have chosen letter C. But it wants the quotient, which is what is above the division sign. So it would be 2x minus 6. So this would be your answer. They tried to trick you on that one. Okay, 11. Solve the equation MP plus NQ equals 1 for Q. Oh, this is a doozy. Okay, so first of all, we're going to take MP and move it to the other side. So we've got NQ equals 1 minus MP. And then if we're going to solve for Q, we have to go through and divide everything by N. I guess this wasn't too bad. So 1 minus MP over N, which is letter D. Got that? All right, let's take a look at what we're doing now. Ooh, exponents. Okay. 3 divided by 9. So this is a 1, this is a 3. And then, so you have to have a placeholder up here. And then we'll have our 3. X to the, you can subtract your exponent. So 10 minus 4 is 6. Those remaining 6 will be left in the denominator. All right, number 13. Let's see, 2 and 4, that's 1 half. And if it's a negative, we're going to take this whole term and move it to the bottom. So our placeholder in the numerator is a 1. And then this will be 2x. And then we're bringing that x to the negative third down. And when we move its location, it changes from a negative exponent to a positive. So we have 1 divided by 2x to the 4th power. Alrighty, and this one, okay, it's squared. So we're going to draw a parenthesis through that and just rewrite it again. So we multiply our coefficients. So negative 3 times negative 3 is 9. And then we can add our exponents. So b to the 10th power. So 9x to the 10th power. And then this one, 4 times negative 2 is negative 8. X and 3 plus 5 gives us 8. Well, that review wasn't too bad. All right. Hope you enjoyed it. Bye-bye.